Perhaps one of the more unique things that have come up in the last like 4 or 5 years that most of us are seeing more and more of is um, the increase in clock rates that we saw in the last like 5, 7, 8 years or the years before that has kind of stopped. Right now, it's all the focus is on using silicon to generate more cores. Right, so systems are going from single core to dual core to quad core, which are quite popular so far. Nehalem's at 8 core. AMD's at 12 core. People are talking about 10 cores and 12 cores and 16 cores. T3 is Sun's latest Spark chip is already at 16 cores. These numbers are large. What that means is for applications to take advantage of the silicon underneath that, it's no longer sufficient for us to just produce really good, do good instruction selection, make good use of cache, figure out, ways of getting the best instruction per cycle kind of thing. What we need to worry about is how do we use all these cores, right? You can use them in many different ways. There are some models of parallelism that are emerging. Okay? This is clearly a very difficult problem in general. So application developers have been slow in adopting some of these styles of parallelism. But yet there are a couple of trends that are more dominant than others. Writing programs in OpenMP is one of them. MPI or cluster programming is another. Multi-threaded programming, which has been around for a long time, is also equally popular. They all have their levels of granularity. In addition to these levels of, so the compiler supports all of it, okay? The compiler supports the latest version of OpenMP. The compiler in Sun Studio has empty hot libraries, okay? So supports them all. There's an MPI analyzer in the product as well. In addition to that, the compiler can also detect parallelism within applications in certain cases. Sometimes called embarrassingly parallel, where you know that there's a certain loop which has certain patterns that you can parallelize for. The compiler is very good about doing it. The Sun compilers have been doing it longer than anyone else in the industry, and so they do a better job of parallelizing that than pretty much any other compiler out there. GCC has just started doing it. Its latest versions of GCC actually have automatic parallelism and OpenMP support. But it's still, in terms of performance, it's still lagging significantly behind any of the larger vendors, including IBM or SGI or Intel or Studio. There's extensive debugger support for all of this. So all the tools support various levels of parallelism, various models of parallelism, whether it's in the debugger or the performance analyzer or the thread analyzer or memory debuggers, things like that. Additionally, MPI is supported with in the profiler. OMPT is a message passing toolkit, sometimes called MPI libraries. Right? That's Oracle official product name for MPI libraries that come as part of Solaris. So I won't go through all of this. We talked about most of this stuff here. So I just wanted to quickly go through two things. One is the kind of support you'll get with Oracle now is even stronger than what you got with Sun. Okay? There's a certain support style and mechanism within Oracle that's applied for most of Oracle products. The tools are part of that same support scheme. So there's Oracle Premier support 24/7. As you can see, this is in line with other Oracle development tools. It's part of the Oracle development tools support bundles. Patches are available only with support, and this is what you saw with Solaris as well. However, the product itself is licensed and it's free. You can download the product. Unlike other products, you can use it to generate production code. You can run that production code without any obligation to Oracle or to Studio. Okay. However, if you need patches, if you need upgrades, if you need to get the ... versions, the next versions of the compiler and tools, until the next significant version comes out that's ready for public download, okay, all the intermediate ones can only be obtained through support. So. So that's all I had here. If you just wanted to point at a location for to get more information, there's a whole bunch of couple of sites. There's forums, there's technical white papers, there's not just documentation but tutorials, video, stuff like that. If you go to this site here, you can get all of that. And I'll try and make these slides available on in the same location where the other slides were that were part of the Oracle Solaris Summit talks. Okay. So you can look at these slides. So it's kind of a quick overview of what we're doing with Studio. I can go deep dive and give you a demo, show you various things. But I wanted to ask you what you wanted to do. Right? First, I wanted to make sure that you had a reasonable overview of the tools, because you may not be familiar with them. And if you wanted me to deep dive into something, fire away. I also recognize it's almost 10 o'clock, so we are all a little sleepy at this point, but I have no clue what time.
Do you have a demo? Can you bring up the ID?
Yeah,
It would be great maybe to see some screenshots of them.
Sure, yeah. There are screenshots, but I can bring up the ID too. Yeah. So let's do that. So this is the last version that just came out a couple of months back. The IDE can be invoked. We had not made the name changes entirely. The IDE can be invoked either as Sun Studio, which was its classic name, or as Solaris Studio, Sol Studio, which is its new name. So when you bring it up, you see a full IDE.
So the full-blown IDE,
oh, yeah,
all
absolutely.
the compilers is free.
Yes, absolutely. The whole package, all the what I talked about as the 100 binaries and 200 plus libraries and all the tools, everything is free. Okay. Freely downloadable. Just go to the site, go to the download
If
site.
you want support or patches, that's where you got to pay for service.
Yes, absolutely. That's the Oracle model, right? There are some minor changes. There are other changes between the way Sun used to do support and the way Oracle does support. So if you're familiar with the Oracle way, then it's uniform. Maybe another a difference that might be interesting or important for you might be at Sun, when we released the product, support kind of started at that point, and then there was a concept of end of life of the product. So there was a date on which you could only download the product up to that point, or you could buy the product up to that point. End of life meant you could no longer order the product, whether it was through downloads or any other means, right? After that point, there was like a 5-year support period that Sun had. Okay, so that was called the
End of service.
yeah. Then there's this end of service period, right? So at Oracle, typically what happens is from day one, your support period starts. For 5 years, there is a support period, and then there's extended support that goes beyond that for 3 more years. Beyond the 3 years, there is still support in the sense you can call up and say, oops, I had a license for something that ran on some other version of the machine. I don't have that machine anymore. Can I run it on this now, right? And you can get questions like those answered now. But you cannot ask for a patch or a bug fix, because 8 years into the product, it gets really hard to produce patches, right? So just from a practical point of view, Oracle or Studio will try and move customers over to the next versions or to a more modern version, right? So that's perhaps the only difference in terms of how you understand support. There are some other support terms that are, every product that is unique in that sense. Studio support is not included as part of Solaris support, at least not yet that I know of, right? So it's still considered what's called unbundled products, so it comes separate from Solaris as well, right? Also because it works on Linux and that's another reason why it's that way. But it's historically been a separate product as well. Historically, in the last 15 years, if you go really way back, 25 years, when I started at Sun, it was part of Sun OS back then.
You need it because you needed a lot of time.
Yeah, back then exactly. You need, wow, you remember, right? So Sana's kernel modules came in source form, and so if you needed to plug in a new module, you actually had to compile it and load it back into the kernel, right? So which meant you had to like stop the kernel, reboot the machine, but you had to actually compile something at that point. So you needed a compiler. So that was one of the motivations for having it. Amazing that you remember.
Way too many kernels back in the day.
So this is 1024 by 768, so I'm not sure you can see a whole lot of lines of stuff here. But in the IDE, there is a central notion of projects, okay, which is what you see on the left-hand side. There's source code here, and then there's navigation. What you see is a class browser on the left-hand side. You can navigate using various things in here. You can go, for example, you can go to where something like this class is defined, okay, by doing a control left click, okay. You can go onto that. Similarly, you can go to any of the variables. You can find out where is 0, right, defined for me. Okay. Same way on the left hand side in the class browser, you can see these. Even though it's called a class browser, it's actually a navigator. You see all variables. You see macro definitions. You see variable names. And if you click on these, you'll see where they are actually defined. Okay. This is classically like IDEs do. Okay. You can also do things like go from here, see where where that is, and obviously it's in one of the header files, which is why you saw that the navigator changing on the left hand side. But you can do things like show me where this variable is defined. Show me which files it's actually used in. So it will give you a whole list of files then, right? And you can do that for variables. You can do that for types. You can do that for classes. So all. Additionally, there's things like code completion in here. So when you start typing in, it'll help you sometimes, annoyingly so. I mean, you can turn it off if you really are annoyed by that, like I am. But there's help for things like that. However, inside, so the IDE is primarily used for browsing. It's used for building. It's used for debugging. Those are the main reasons why people use IDEs. Then there are various other tools that are sort of hooked into it. There's a source code control system that's part of the IDE. Okay. Then there is a projects management system. There's something called Kenai. So basically external services that you can go access. The IDE also hooks up to a continuous integration engine. However, some of these features are not, C++ users don't use them as much. The Java and dynamic languages guys use continuous integration a lot more than C++ guys use. There was a Sun project called Hudson that basically the IDE integrated with. So if you checked your code back in, it automatically launched a build for you at that point. So there's integration for things like that. At the very basic level, you do compiles and builds, right? So you say, clean the whole thing and build it for me. Okay, easy enough. It's gone ahead and done that. There is discovery mechanism inside the IDE that says, how many compilers do you have? What kind of compilers do you have on your system? And it will list all the ones that you have, right? All the versions, and then you can say, that's the tool chain I want. And you can configure by saying, my make file means, in my make files, a build means this, a debug build means this, a production build means this. So you can give it all the options for all of that. Okay. So let's just run the project. Let's just run the application and see. When it's running, you will also see. So this is normally that's not as annoying in a 1024 by 768 screen it is. You can see on the left hand side there is a run monitor that's running there. Okay, you can see that it's showing you CPU usage, it's showing you memory usage, and it's showing you thread usage. Okay, these are the default dtrace instruments that it uses. Okay, so underneath the covers basically uses dtrace instruments. On Linux it uses equivalent instruments. On Solaris, it basically just uses dtrace as is. Gives you hotspots. You can go in here and get a list of hotspots here. Okay, when you get a list of hotspots, it'll show you function names that you have access to, and then things that you do not have access to. So these things that are colored in dark, you have source code for. Things that are not in light color, you don't have source code for. Click on one of these, and it will go to that and show you annotated, how much time is spent in this function, exclusively in this function, and by functions that are in this function as well, that are called by this function. Okay. So you can use that to get a quick idea of where you are spending time. Okay. And this is of course beautifully sorted by time order, right? I mean things like that. Same thing with leaks, right? You can go to leaks and get a leaks report, right? And in this case, it just so happens that there's a whole bunch of calls to operator new, which is not all that uncommon in C++. Also not uncommon in C++ is there's no delete operator. There's no delete function that goes with it. So it's taking up memory, and you can see some leaks there because of that. Okay. So there is this. There's of course a debugger embedded in this as well. So there's a debugger. There's a profiler in there. There's navigator in there. There's source code editor in there. So it's all this is a fairly rich IDE. Based on NetBeans, based on the latest version of NetBeans. You can download a version of NetBeans that has something called CND or C++ modules as they're called. They do an equivalent set of functionality on Solaris, and as part of Studio, there's more functionality than just what's in CND. CND is a more platform neutral functionality. You can get it on Windows, you can get the same thing on Linux, you can get the same thing on Mac and on various Unixes. NetBeans is across many platforms. So there are things in here like this profiler here, the quick profiler, what we call Delight, that are specific to Solaris. Additionally, you can do a lot of these functionalities, a lot of these actions in separate standalone tools. There's a separate standalone profiler that gives exactly that kind of thing. You can go deeper into it a little bit and do more things. Same way with the debugger as well.
Does the NetBeans have that dtrace bagged?
No, it doesn't. No, it doesn't. Yeah, right.
I've never seen that.
Yeah, on NetBeans has something. If you use vanilla NetBeans, there's a little thing on top that shows you what your memory usage is. You can get that out of JVM. Okay, so it makes calls.
It's not like that. Right?
It's not like that, right? This is much prettier, right? Yeah. That's.
What's on the team menu?
Oh, right. So those are all the team actions. So things like source code control, like CVS, Mercurial, Subversion, things like that, right? And it's got integration into things like Bugzilla as well.
Oh, okay.
Yeah.
What's
So
the little chemistry bottle here?
this one here?
Yeah.
What is this chemistry bottle here?
So there's a lot of stuff there.
Yeah, there's a lot of. Oh, really? Okay.
Maybe it's not a chemistry bottle.
Wow,
I don't know. I never use data races from within the IDE itself. There's a separate thread analyzer that gets you data races and deadlock detection, basically. Okay. But
I don't get races and deadlocks out of that bottle. Maybe it's
yeah, it's not a very intuitive icon, right? So
yeah, a lot of tools there. Wow.
there's a whole bunch of tools in there. And we don't care how users use them, whether they want to use them from within the IDE or individually. That's all fine, right? We support all of that. Another interesting thing that's part of this is you can go to this project and like we said, build. You can actually go to a remote host and say, I want to not build here, but I want to go build on that other machine. Okay, and when you do that, you can tell it what's your host name, and when you tell it that I want to go build it on that machine foo, it'll actually go to that machine foo. It'll go figure out what tools are on that machine and tell you these are the tool chains that are available. How do you want to configure it? There's of course a default. You can just click through and say yes, 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 does done. Okay, but then you can or you can individually configure for various things as well. Okay? So it's very rich. However, as you see there, okay, and this is one of the biggest things that many classic Unix developers don't like about IDE is when you start up the tool, basically it scans the project. So whatever you give it, a bunch of sources is a project for it. Okay, so in order for it to know, for it to do navigation, in order for it to know how to do builds, it takes your whole make system, build system, whatever form it is in, and it creates a project out of it, and it works on that as a project, which is great for a large number of developers, particularly those who are new to a Unix platform, right? New college grads, many people who come from Windows, for example, are very familiar with an IDE. For them, this is great. But for the Unix guys, they go, no, I don't want to load a project just to do debugging. Okay, just give me a debugger. That's all I want. Okay, and that's why we're fine with that. Nothing wrong, right? Takes different types to be on of developers to be on Unix, and we try to service as many of them as we can. Same way you'll see in the compiler too. There's a whole range of options. Not only range of options to do optimization, but to do a whole bunch of things. We are also very careful about trying to be compatible with GCC. There's a whole set of features that we have implemented that take in a lot of GCC code that can be compiled with GCC also in our compiler. We put in a lot of effort to make sure open source applications also work with our compiler.
So you can compile not C code to C code.
Yeah, well, right. So in compiler land there is the language standard, right? And then there's how people write code. Okay, and if you find a piece
No,
of
I'm glad you did it because it's annoying having to call out GCC because somebody couldn't write real code.
yes, right. So it's the compiler guys are as much as they are language lawyers, they also understand that when people write programs, those who are writing the applications are not all language lawyers either. They are not sitting with the language standard in front of them when they write. Would make our job incredibly easy if if that were really true. But so we try to be as accommodating and as open with all of that as we can. So I hope I gave you a flavor of the kind of things we have in there. Strictly from a strategic point of view, right? I keep people ask me the question when I go to various customer sites. Now, what's Oracle going to do with compilers? Do you really need compilers now, right? Just or is the whole strategy changing, right? Oracle has stood behind Solaris. Oracle has stood behind Sun Systems, and by that same implication, right? Compilers and tools are necessary to develop a vibrant ecosystem around any operating environment like Solaris. So I expect to see reasonable support going forward. The same sort of dedication or the same focus that we've had on optimizing systems, it should work for Oracle just like it worked for Sun as well. Okay? Gives a certain leg up for Sun systems that over other competitive systems, even on the x86 side. After all, Dell's producing machines too, so is HP and IBM, and everyone's got x86 machines. Oracle needs something to give them the edge over everyone else, right? So and we do our part basically in that. So okay, any other questions? Hi, yeah. No. Oh, okay. Yeah, that's fine.
I have a
Yes,
question.
yeah.
12.2 is out now, right?
Yes. This is what I showed you is the latest one, 12.2. Yes.
I keep forgetting to check my build 151, but 150, the repository only has update 1. Is this
Correct.
going to be in the released Oracle Solaris 11 Express, is 12.2
Yes.
gonna be in there?
Yes, it will be.
Okay.
There is a slight bit of disk. So what I don't know is exactly when that will happen, because the Solaris repository itself is right now in build 150 and 151 only contains Solaris bits, the bits that are supported as part of the Solaris contract. The other bits will probably show up in the extras repository or in a separate repository. That it will be in the same Solaris tree, but may not be under Solaris as a package. We'd love to be in the same package thing, so that you don't need to go somewhere else to search for compilers.
Okay.
However, I think that is still an open question. I don't know where exactly it will show up.
You can certainly download it, which is what I do.
Yeah, you can. I mean, you can get.
No, I get it in,
yeah.
I get it in the 150, it's in that repository.
No, it's not actually in the repository. I
If you
think
go to
you're getting from a
iPack-
previous
if you go
version.
to iPackage dot, summit.
Yes, right. That has things from open
It has update 1.
2009, 06, and around 134 time frame. I think that's when it got submitted.
Oh, so it's in there with the new one.
The new one
Isn't-
hasn't made it in there. And we have the bits. We just don't know where to put them. So
Oh, wow.
yeah,
Okay.
we'll it's getting worked out. So
Okay.
might be a week or so before it actually shows up there, but it'll be there.
Oh,
Yeah.
okay.
And we'll through blog and through our this thing site, we'll let you know exactly where to go look for it, right?
Yeah.
Um,
Good.
Thank you very much.
Thank you.
Thank you.